Slightly being a Liverpool team, I can talk quite quickly, so we should be able to rattle through things quite easily. Quick introduction to myself. My name is Jason Cargill. I'm technical specialist for Flir in the UK and Ireland. Interestingly enough, for those of you that don't know, FLIR actually stands for forward-looking infrared. So our products do what it says on the tin. And it's a company that's been, since the 60s, been involved with thermal imaging. Full transparency from my perspective, I am neither a marine surveyor or a marine thermography surveyor, but I am a level 2 qualified thermographer, and the applications for thermography can be used in many, many different applications in regards to areas of work. For me, I've learned a lot even in the last few days in regards to marine surveying, in regards to the type of tasks and activities you have to undertake. Interestingly enough, I've actually got a cousin who lives in Warwickshire who's in the process of buying a vessel, and he's been talking to a marine surveyor today. So there you go, small world. So I've got a number of slides. I'm not a massive fan on death by PowerPoint. I brought a few cameras with me. We have a little demo case set up over there, which gives a simulation of some wiring faults, for example. So as I say, we've got kind of 25 minutes to try and rattle through this. What I will do though is I'll leave some of my cards. If you have any questions afterwards, by all means, send me an email. More than happy to help. You know, we have a lot of collateral in regards to thermography information, but marine surveying is a very specialised subject, and I'll need to do a bit more digging to get exact. So you mentioned before about images and copyright and things. I've had to be very careful with my presentation. And hello to everybody online as well.
They can't hear you now.
Can't hear you now. Can you hear me?
Yeah.
Sorry, folks. Anybody else?
It's not coming through the mic. It should be now. That should be better.
Hello?
Can you hear online? Can somebody give us a thumbs up or?
It'll come through the mic.
Don't mind hear me.
Yes, thank you, thank you, thank you.
I don't know about hear me. Can you understand me? Normally need a translator. So this is just a very simple introduction to thermal imaging. Again, from a shop perspective, the amount of environments that I operate in tend to be industrial based. Also with some building applications as well. So you look at building envelopes, performance of buildings from an energy perspective. But predominantly our equipment is used for electrical, mechanical process kind of fault finding. So from a vessel perspective, there's certainly those systems you have for coolant systems, mechanical systems, electrical. The interesting one for me has been about the composite materials which are used within vessels. I mean, I know reading up on the subject, moisture meters are used a lot for looking for moisture within composite materials. Thermal imaging can be used because the performance of moisture from a thermal capacitance perspective, and what that means is any areas within a hull, for example, which are retaining moisture, will retain heat longer than the air around them. So any areas of a vessel that don't have issues with moisture, they will look differently on the thermogram. So why use infrared? So infrared is a non-contact form of analysis, non-destructive testing. It means that you don't have to gain access to any materials. You always look at the surface condition of a material. So it's non-destructive. That means it's far easier to carry out, even when there's people around as well, you know, just for examples in rooms like this. Interestingly enough, from an infrared perspective, everything in this room is emitting infrared energy. The walls, the ceiling, the floors, your shoes, your hair. Because infrared starts to be emitted at 0 kelvins, and that's minus 273 degrees centigrade. So we have this perception about thermography, it's all about heat, but actually it can be used for other applications as well. You know, our cameras go down to minus 40 in some cases. The majority of the range is minus 20 degrees C. But certainly it can be used for refrigeration, HVAC applications as well. One of the biggest uses for thermography worldwide is the tracing of water leaks. So as water evaporates, it cools and it leaves a very, very clear signal on your camera. Very, very easy to trace. So the beauty of thermography as a subject is its applications are very, very diverse. You can invest in a camera for 1 or 2 reasons, but you'll find quite quickly that within
a matter of weeks, there's a huge amount of different applications you could use the equipment for. So from our perspective, that return on investment is kind of really important. Really, the bottom line here is the most important. It's like having a superpower, which sounds very dramatic, but you can see what's invisible. And from the maintenance perspective, being able to see something failing before it fails, that is like a superpower. And again, I can't talk about personal experience on vessels, but certainly from production facilities, any kind of downtime costs money. And ultimately, that's what we're trying to avoid, trying to get to a predictive, preventative maintenance type of action. So, very, very basic theory, the electromagnetic spectrum, we sit right in the middle of the spectrum in regards to what our cameras can do. Now, the cameras which I am responsible for are called uncooled cameras. So therefore, they are cooled by the ambient conditions. And they are classed as a long wave camera. We have other cameras within the Flir range which have cooled bolometers. So they use liquid nitrogen to cool the detector down to make it more sensitive. But there's a massive upswing in cost as well when you start going into the 80, 90, 100,000 pounds for a cool camera. And I've literally got a camera sitting on that table there that costs 500 pounds. And it's a very good camera and it's very, very capable. But by the same token, there's another camera on there that costs 20,000 pounds. So the range is really diverse, and it's all about what applications do you want to use it for, how important is it for your business. And when I was listening to your presentation before, the reporting side of things is really important from your perspective in regards to the evidence and the data. And the one thing we do really, really well is the reporting software. We have a number of options. Some of them you have to purchase, some are free. Allows you to analyze and create reports in regards to producing the evidence to then store for future reference. Snapshots of the Flir range that I deal with, and again, the Flir one is at the top of the screen. That's one of the latest developments we've had. You may be familiar with the little Flir One plugins that you plug into the bottom of your phone. You might have seen them. That's the next generation. So this device is now compatible with Apple and Android. It can be used remotely, so you can use it to look behind areas while your phone is separate from the device. And again, you'll be able to see this by the time we finish today. So we've got a diverse range. People talk about resolution, numbers of pixels. Pixels are important for thermography because we talk about detectors. So we have a detector which sits in the camera. The detector is a certain size dimension. The way I equate it is an Excel spreadsheet. For example, we have the little camera mentioned, the Flir One Edge. That's a 160 by 120 detector. If you had a worksheet that had 160 columns and 120 rows, you'd have 19,200 cells. Each one of those cells has a temperature in it. So even in the small camera, which is a minimal investment, there's still a huge amount of data in the thermal image. But as you'll see on the screen here, we go right up to the T1020, which has 786,432 pixels. We also have an additional feature called Ultramax, which essentially pumps that up to 1.2 megapixels, which for any thermal image is huge. But is it needed for every application? No. The Flir One Edge Pro will do a very good job in a lot of applications because it's still sensitive to 0.07 of a degree centigrade. And what you'll tend to find with industrial applications, or mechanical or electrical, the temperature differences are quite high between faulty items and items which are operating normally. And what we're looking for with thermography is a difference in condition. And I've got some slides that show various aspects of some electrical and mechanical. But don't get too hung up about resolution and numbers of pixels. It can be important in certain applications, especially over distance. So companies like National Grid will use the top of the range T1020 camera because they'll be looking at electrical towers and pylons, maybe from 1,000 meters away. Having the additional resolution is important then. And then you also then talk about additional lenses. No different to your typical photography with a digital SLR camera. You change the field of view dependent on the glass on the front of your lens. The difference with thermal cameras are the lens is made of a metal called germanium, which is transmissive to wavelengths. I don't know whether you can see it clearly over here, but this is the side of a building. This is one public class is a lower resolution camera against a higher resolution camera. You can clearly see the edges are clearer, there's more detail because there's more pixels. Now, as I say, for certain applications, it becomes more important. I'd say for the majority of the industrial applications, and we'll include marine into that, a lower resolution camera would be fine. Because even, as I say, the entry point now, we've got really good thermal sensitivity. Because you might see when you look at specifications, they talk about millikelvins. That's how the figure we use for thermal sensitivity. Our lowest millikelvin rate is 7. This again, just other images from a distance. This is why I talk about places like National Grid using high resolution cameras and different optics. It looks different on the screen, and therefore it would look different in your reports as well. I've kind of already alluded to this, but our cameras capture what's called a radiometric JPEG. So the radiometric JPEG essentially is an image with temperature data embedded in it. So that analogy of a thermal worksheet in Excel, for example, that's where that data really can be found. Now, you can open these images on a normal PC just as an image, but you wouldn't be able to analyze it without the software. So if you just want to send an image to someone, you can do that quite easily with any Flir camera. You don't need to use the radiometric side. So what we've got on here, this is on the right-hand side of the screen. This is in effect looking at, this is a rendition of a detector, which is inside the camera. You can see there's many pixels on there. But then we have one which is being enlarged, and that's called your instantaneous field of view. So that means at a certain distance, what size of an object can I detect with my camera? And that will depend on the resolution. So essentially IFOV, again, if you're ever looking at specifications, you'll see that specification. It means the size of a pixel, usually from a meter. But then there are facilities on the Flir website to do calculations on different lenses. As I say, the subject itself, because it's anography, it's kind of, you know, do I need to go to university to study the subject? No, you don't. You've got to apply some common sense to a certain degree, and also a little bit of knowledge of the subject matter that you're looking at. But, you know, yeah, I'm level 2 because I work for Flir, and I'd be worried if I wasn't. But you don't need to be a level 2 to carry out a thermal survey. I'd certainly advise from a training perspective, level 1 ITC course, definitely worth doing, because A, it gives you the kudos of having a qualification when you're providing a service to your clients. But it also gives you a far better understanding about subjects like heat transfer. Because understanding heat transfer helps you to utilize the camera to get the best information. Because, as you mentioned before, thermography is fantastic. You know, I am a massive fan, but it can lead you down the garden path if you don't know a little bit of information. You know, just because something looks hotter than something else doesn't mean it's about to burst into flames. But what it means is you may need to look further at that subject. And then you start looking at what's the normal operating conditions, is it within specifications? But there's no better technology than thermography to give you that early warning system. That can be covered on so many different applications. So pixels on target is what we tend to talk about. So this IFOV is a calculator which is actually on the Flir website. If at some point in the future you're investing in a camera, you're interested in maybe you need to look at a subject a little bit further away, you can put a lens combination in with a distance, and it'll give you the IFOV at that distance. So as a simple one here, we've got IFOV with a certain lens, a meter. The pixel's just less than a millimeter across. If you go up 50 meters, it's 45 millimeters across. So as you go further away from the subject, it's enlarged on the detector. Have I lost anybody yet? Are we all still with me? Anyone got any questions, by the way? As you can probably tell, I'm not using the script, so.
Yeah, the question online from Gary, what temperature sensitivity is required to detect moisture in our GRP laminates?
Well, honest answer, I don't know anything about GRP laminates, but 0.07 of a degree centigrade will certainly give you an example of a low pickup of emitted infrared radiation. I don't know of any specific figure. I mean, we'll make a note of these questions, because from my perspective, I'll go away, and if I can come back with an answer on the subject, I'll feel a lot cleverer next time I talk about this subject. But that's where you get into the real, from a vessel perspective, because I believe in some cases you have to take cores out of certain materials and test them and that kind of thing. So thermography will only ever give you a surface temperature. this is one of the popular misconceptions, thanks to the likes of CSI Miami and other cop shows. You can't see through hardly any materials with a thermal camera. When you pick the cameras up shortly and you look in these glass windows, you'll see very nice reflections of yourself in the room, which is bouncing off the glass and going back into the camera. So direct line of sight is imperative for any thermal application. But if you look at a surface, and if this was the side of a vessel, for example, if there was moisture in a part of this vessel, if you've applied some heat and then you give it time to dissipate, the area with the moisture will still appear to be warm. It's the same way that we use to detect leaks in flat roofing systems. Because if you've got a leak in a flat roof, there are certain other ways and tools that you can use, but ultimately, you let the solar energy pump into the roof, the sun goes down, you give it time to dissipate, and then where there's moisture, the higher thermal capacitance will leave a heat register. So it's a really clear way of identifying problems underneath the surface, but it's only by looking at surface conditions. I probably really didn't answer that question. That's all, by the way. But I will try and get an answer. Emissivity, unusual word. I'd never heard of it before I came across thermal cameras. Emissivity is basically a measurement of a surface's ability to emit infrared energy. So you will notice on here, so this is just a small, bought off Amazon hand warmer. But what I've put on the middle of the hand warmer is a piece of copper tape. Coincidentally, for getting rid of slugs in your garden. But what I can show you is when you look at it with the camera, that copper will look a lot cooler than the hand warmer itself. But by conduction, they should all be the same temperature because it's fixed to the surface. But it looks cooler. And that's kind of one of the little sort of bits of knowledge that come and help you get a long way with thermography is be aware of the surfaces. If it looks shiny to the human eye, it's going to have a lower emissivity. So if it's copper, for example, you've got to be a bit more careful. You can adapt for it in the cameras, but ultimately, it's that bit of knowledge which will really help. MSX, multispectral dynamic imaging. I don't know where the X came from. It's the sounded cooler in marketing. But ultimately, what we're talking about is a really, really useful function on the camera, which will allow you to enhance the detail of the thermal image. Because when we have the cameras, and you'll see yourself, but we have the larger aperture on any camera is the thermal lens. So that's your germanium lens. But then you also have a small digital camera, in these cases 5 megapixel. Every time you pull the trigger to record an image, it takes 2 images at the same time. It takes the visual image and it takes the thermal image. What MSX does, it embosses, that's just a thermal image. But as you can see on this one, there's more detail. The edges are clearer. For example, on this MCB board, you can see the numbers of the terminals. If that was just a thermal image, you wouldn't see that detail. So as MSX is, it's function on every camera that we sell now. It's really useful to help you as a user to enhance not only the report you give your customer, but your understanding and your interpretation of what you're looking at as well. Ultramax I mentioned before, essentially it quadruples the number of pixels in your camera. This is a bit of a closer look at resolution, detail and pixels on target. So what we can see here is we have a target, which is we class as a thermal anomaly. Based on this detector size, we are also taking some of that temperature from behind that anomaly, so the background temperature. So we haven't got enough pixels on this target. So we either need to get closer or we need a higher resolution camera. So we have 26 degrees at this state. We've now, the temperature's gone up to 37, but that's only because we've got more pixels on the target. So it's now covered with more pixels. And then we go to this, up to 48 degrees, the whole anomaly is now covered with pixels. So this is another thing in regards to what data does a thermal camera give me? A thermal camera can give you a temperature, but is it a temperature of the exact item you're looking for? Are you really interested in exact temperatures? Or are you interested in condition? Because we have qualitative and quantitative analysis. Qualitative analysis is, I've got 3 fuses, the fuse on the right is 30 degrees hotter than the other 2, then the condition is different. They're all under the same load. There's clearly a problem with that one fuse. So that's qualitative analysis. Quantitative is if you're really looking at the data, the detail. What temperature is this item? What temperature is this cable, this terminal? Another feature on the cameras, which again, just to show you, because one of the things about getting the most from your thermal camera is being able to thermally tune the camera. And what that normally means is you make some changes to enhance the object that you're looking at. We've now built a feature into the cameras, which is called one touch level and span. You have an object on the screen, you touch the screen, it will automatically calibrate. We finally discovered there's a Scouser in the building. Oh, okay. So one touch level and span. You touch the screen. Well, that didn't work. Anyway, take my advice, I'll show you in real life. Essentially, when you touch the, I think it's because we've changed over the machines. Touch the screen, it'll enhance the image of what you're looking at. So, for example, when a camera looks at a field of view, it gauges every piece of surface temperature it's looking at, and it sets the range to suit. Now, you might have a halogen lamp in the corner that you're not interested in. You might have something emitting a very cold source from another part that you're not interested in, but the camera's going to go from both ends of the spectrum. And what that can mean is you then miss what you're actually interested in. So it's a really, really useful feature, one touch level and span. I will show you on the cameras. This also would look really good as well, this one. And this one also would look really good. But you'll just have to take my word for it. This is kind of the effect of different lenses. You know, so standard 24-degree lens from the same position, put a 14-degree on, it's like a telephoto lens. It brings the object closer without you having to get closer. I realise I'm rattling through this, by the way. So, and then the telephoto lens, which will be a 6-degree, will bring it closer again. So, highly likely in your environment, looking at vessels and small yachts and small boats. And I'm conscious to get the names right.
And ships as well.
Yeah, ships, vessels, yeah, floating structures. Yeah. Whether you need to look at something that far away, probably not. Most of the things you look at generally I would expect to be quite close, and therefore closer is always better. The best thing you can do with the thermal camera, if you can, if it's safe to do so, is get as close as possible to the object you're looking at, and that'll give you the best result. So this is actually relatable to marine, and this isn't a Flir slide, as you can probably tell. But these were the names of, when I was Googling about marine surveys, and I might have Googled some of your own sites, I don't know, but ultimately, thermography can cover all of these areas competently and with ease. Mechanical breakdowns, generally easy to spot. You know, they're generally in the form. Motors is one of the big ones, because, you know, one of the worst things you can do with a motor is run it above its normal operating temperature, because the life of that motor will be reduced substantially. The life of the insulation creates hot spots and the knock-on effect of that. So mechanical breakdowns, coolant blockages. Again, we're looking at surface condition. If there's coolant in a pipe and it's blocked, then that pipe is going to look different where the coolant is housed to where it hasn't travelled. Again, it's a very visual thing, easy to spot. Fuel systems, electrical faults, you know, certainly one of the biggest that we use from our application of our solutions. Composite materials is definitely, it's a function for thermography. There's certain, you know, you do have to apply heat in order for the moisture to be heated up and then the retained heat to show up on the camera. But ultimately, it's, from what I've seen on the internet, there's quite a lot of people doing that for composite materials. I then went down a rabbit hole with various types of fiberglass and fiberglass matting and all kinds of things I didn't really understand, but it just enhances the interest. And then proof of work, you know, if something gets repaired, you can always use the camera to prove that the repair has been done correctly. So it's further evidence in effect. Right, applications, and I'm going to rattle through these so you can get your hands on some cameras. But essentially what we're looking at here is we have, in fact, how do I get rid of this, David?
Right at the top, right at the top.
Right at the top up there. You think I was a technical specialist, but not for Zoom. So what we're looking at here is with the visual spectrum, you know, okay, there's nothing unusual, can't really see any signs of overheating, because this is another thing people don't really think about is, even if you have a thermal camera, use your eyes first. Sometimes insulation can look like it's burnt a little bit, or there's visual things you can lock into with your eyes. But what we're looking at here is we've got an unbalanced circuit. So quite clearly one of these phases is a lot hotter than the other two, so there's an imbalance in the system. Now you might use a clamp meter or another test tool to gauge what that is, But that's just a quick visual indicator that the condition of this particular image, we need to look further at that particular subject. And then the beauty of things like reporting and analysis software is you can put markers on to those points that you're interested in. You can draw heat profile lines to, you know, you can really produce a really either detailed or really simple report. So flip side is, in this we have an open circuit. Not a fantastic image, by the way, it's not mine. But these two are showing the performance under load. Whereas this one, there's no temperature at all, no radiant energy. So it's what it shows there that there's an open circuit. That's a different type of problem to take a look at, but it's a clear thing to be able to see with a thermal camera. In this case, it's an energized ground cable, but if you've got a cable which is in a position where it's carrying too much current, it'll show up very, very clearly on a thermal image. This is the motor. What we can see down the bottom here is we've got a particularly hot area. So this is going to be breakdown of the insulation within inside the motor. It's radiating through the case of the motor. So in that one space, we have what's called a hotspot, which is shown on the surface. And the interesting thing with motors is, regardless of what the surface temperature is, because it's an enclosed space, you can be sure that the inside temperature within the motor is at least 20 degrees higher. So motors is a good one to pick up with thermography. Contactors. So we have an issue here on this one particular contact. There's two main issues you get with terminations. You either get a hotspot where it's screwed onto the contactor itself, and then it dissipates to a normal temperature. That's indicative of a loose connection. So a loose connection will vibrate very, very quickly. It creates this friction and heat. Easy to spot loose connections with a thermal camera. This case on the right here, we have a motor which is coupled with a bearing, and you can see that there's through conduction, these should roughly be the same temperature. But as on the right, it's a lot warmer, and that's because there's a problem with the bearing on that motor. So again, it's a quick indicator that there's either misalignment or could be something loose. But again, quick indicator in regards to a mechanical problem. Steam and fluid lines, quick snapshots. If we were just looking at this normally, everything would look normal. Even if you'd have to go around with a contact thermometer maybe, or a spot thermometer, but even then it's only giving you numbers. Ultimately, a thermal image just gives you a very unambiguous, this is the condition at the time. Now, you can analyze any image with the software. You can have as many spot markers as you like. As I mentioned, profile lines, you can really dig into the detail. But ultimately, a thermal camera will give you a good result based on some basic knowledge of what you're looking at and the environment that you're in. And so it's kind of those little basic tips which can help. I mentioned about fuses before. So 3 fuses, the one on the right, clearly there's a potential problem. But we would check that circuit, because if the circuit's operating at a higher temperature, it's going to look hotter anyway. This is why it doesn't always mean that there's a problem. You know, a thermal image doesn't mean because something looks hot that it is a problem. You just need to look a little bit further to either confirm it is or that it isn't. This is a really good one of a loose connection, taken with a high resolution camera. This is the effect I talk about going to ambient with the cable. So that's a copper cable. So the heat, if it was a problem, it would be this, it would lit up like a Christmas tree all the way along. So this is indicative of a loose connection. Again, very, very easy to spot. And I've done demonstrations in various facilities where I've found loose connections. They're the kind of the demonstrations from heaven, because that's exactly what you want to find. But just to prove the capabilities of the devices. You know, we've got a section in here which, you know, it's really complex. There's a lot of cables, but we can quite clearly see that there's potentially a problem there. Not guaranteed straight away, but it's potential. So these are kind of just other images where there's a bit of analysis in the top left-hand corner of this image. So there's been 2 boxes drawn on 2 sections of interest. Those boxes are just tools that you can choose, put onto the image, and it gives you the data straight away, the minimum, maximum and average temperature within that box. You've got tools where you can draw ellipses, you can do a freehand around a particular area. Analysis is a huge amount of one of the selling points and the strength points of producing good reports. We look at this image here, where we've got, again, these are anomalies. I don't think you'll find one of these on a ship, by the way. But ultimately, it gives you an idea that even from a distance, you can pick up a problem. You don't even need to measure something from a distance, but ultimately, if it's showing up on the camera, there's an anomaly to look further at. Duct inspections as well. You know, are the ducting systems, are they leaking? Are there any problems? Have you had a breakdown of insulation maybe in some cases? So there's heat starting to, or there's thermal energy starting to be emitted through them. Lots and lots of applications that you can utilise. And the thing from my perspective is, I cover UK and Ireland. My job is to travel around extolling the virtues of thermal imaging. My best way of doing that is to try something in situ. So, you know, even if something to leave you with today is, if you're in a situation where you want to see how a thermal imager can perform on a vessel, give me a shout and we can learn something together. Because it's again, you know, electrical mechanical things, yeah, easy. Just very, very obvious. But fusible, then this is just an example of a condenser. You know, from the outside, you would never know there was a problem. But clearly with the thermal eye, you can see that there's an issue here. I'm going to touch on the software ecosystem. So if you look on the Flir website, it's all the word Flir Ignite, used a lot. Flir Ignite is a cloud-based service which can be linked to a camera. So you create an account, you can link one of these. Pretty much all the cameras now, by the top of the range, is used for that. You open an account, so you get a gigabyte of data for free. And bearing in mind, most thermal images are about 700 kilobytes. That's a huge amount of data that you can record. There's reporting and analysis available on there as well. So it's a free system. We also have Flir Studio, Thermal Studio, which is a bit more involved, allows you to do things like batch processing and stuff like that. And then, for example, on the little Flir Wedge. So this is an app-based system. You're going to see I'll connect it to my phone. So essentially, your phone becomes the receptacle of the data. So your photo gallery will have the images stored. You can then utilize that how you like. You want to send it on a WhatsApp, add it to an email. It's really flexible and it's really easy to use. So I'll show you that shortly. That's kind of they're kind of the three software programs. Not bad, that 30 minutes. It's good. I realised it was a bit of a tsunami of information, probably the wrong terminology in this room, but ultimately, by all means, contact me afterwards. Thermography is fantastic. I mean, it really does give you, it puts you a couple of steps ahead when it comes to finding problems. And I realise because I've got this on my shirt, I've got certain biases, shall we say. But I first came across thermal imaging in 2006 when I joined Fluke, and I saw the benefits of it even then. So, any questions? Apart from get off?
Can your Flir see what gases, like exhaust gases, rather than a solid that's composed?
It's difficult with gas because we do have cameras in the range to actually see gases in the air, but because we're looking at temperatures, you'd need to have a surface near where the gas was being emitted. So you'd have an element of the infrared against the wall, so you'd still have a solid surface. You may, in certain scenarios, if it's really contrasted temperature, but usually it has to be a surface more than a gas. Although we do have acoustic cameras now, which I've actually brought. Yeah. Yeah. Yeah.
It's quite a long one. When people
Okay. So it's from Gary. In Canada, we are often requested to survey GRP in temperatures below 0 degrees centigrade. Can Flir recognise frozen moisture as separate from GRP that is also at a similar temperature? Would a higher degree of temperature sensitivity allow us to distinguish would a higher degrees of temperature sensitivity allow us to distinguish the potential moisture?
Very good question.
You don't know the answer.
No. I would say thermal contrast is kind of the most important thing for thermography. So whether it's thermal contrast at a higher temperature or a lower temperature, for example, if we were looking at a wall here, that's 20 degrees, the room 20 degrees, there's 20 degrees water dripping down the wall, we're not going to see anything because there's equilibrium effectively. So again, this is definitely one for me to take up afterwards, but thermal contrast, if the camera's capable of going down to a certain temperature, as I say, with our range, it's -40. If there's a thermal contrast between -40 and 0, camera should pick it up purely because of the thermal sensitivity. So I would say, based on my limited knowledge of the subject matter, it should do based on the capabilities of a thermal camera. So I'll take that. I'll take that one.
Yeah, Simon's popped up, say it can only see difference in temperature, so you would need to apply heat to look for differences in warm up. Best not to survey in 0 degrees.
Right, that's fine.
So,
Yeah. Can you give me his number?
thank
Oh, I see. Was that one of these questions that catch me out?
you.
Call me out.
Thank you, Simon.
Thank you for the question. Be nice to have someone can answer that. Oh, I've got another question. It's not about GRP composites, is it?
It is actually.
Oh, right. Well,
Sorry, I'm a late arrival, so it's fascinating technology that I've seen used elsewhere. I just wonder whether it is capable of identifying electrolytic action within a carbon fibre composite. Would it?
tell you what, they're coming out with the doozies now. Well, ultimately, it gives you only a surface temperature.
Okay.
So it would depend on what kind of effect that has within the composite. So through the conduction, the heat will always go to cold.
Yeah.
So it will try to make its way out to the surface.
Yeah.
So again, honest answer is, I don't know. But this is another question I'm going to take up and add it to the raft of other questions I can answer.
Yeah.
Because it's such a complex subject, I think, when it comes to these materials.
Yeah.
As I say, I can apply a very simple flat roof analogy in regards to finding where moisture is.
Yeah.
Applying heat, for example, and waiting for it to dissipate. But
yeah.
I think these are definitely more. I'll need to look further into these to get you an answer. But I will get you an answer. I have enough witnesses now. I have to get you an answer.
It's worth just saying, I certainly know of surveyors who use this technology, and they do believe it gives them an extra edge. I mean, they've taken the time to understand the technology, understand what they're seeing, and that is important to know what you're seeing, and then you can report it. So it definitely would give you an extra string to your bow, for sure.
Yeah,
We're going to have a play, are we?
Yes, yeah.
Okay.
So if you want to,
on,
don't want to go over to fully understand the email, let's get them to eat.
For the guys online, I'm going to try and use this camera here to.
Well, have we got a plug here, which I can socket here?
Yeah.
So you got to point it down.
There's a socket there.
So essentially, all those boxes, it's showing some wire faults in the real life. So it's simulating potential problems that you find in the camera. It's typically just a standard unit that we use. Also shown here, there's an underfloor heating mat underneath as well. So, and this also indicates the effect of the humidity that I mentioned before. So, can we? So the box here, can you point the camera down? Yeah. If you can get it down on there. By the way, don't point. Come on, look, guys.
Don't be shy.
Don't be shy, I'm not.
Yes.
So essentially what you do with this camera, let me go keep the rotator. Yeah. The benefits in this case is you can be able to show subject matter. So you got an ability here to focus yourself, or there's a focus on the camera, so there's top bubble. So that's a great. So I'm just going to show you. Can you see the screen? That's the kind of effect that you're going to get there. Essentially what we've got here is simulating the overlay cables. So you can see this one in the middle here. In a real life scenario, that's what it would look like.
And this is one when you.
This one you click onto your iPhone.
I'll show you now. It's,
So is that showing sensitive heat there?
I'll get, yeah, it's the blue one, second.
in the, yeah. Put this one in.
Yeah, interesting. Wow.
It's on that. One of these. So that's a fixed focus camera, so there's no focusing to do yourself, it's just fixed focus, so it's got a.
And the trigger's just taking images.
Yeah, so you pull that trigger and record the two images that we saw before.
And the bit you talked about, the spot image that you can tap on.
Yeah, yeah. So we just have to put minutes on landing now.
Right.
You switch. Just highlight. So you touch anywhere on that screen, I'll recalibrate to what we're looking at.
Yeah. This is the 20 grand.
Yeah.
So where are we in the range? That's the very.
So the ones I've brought today, that's the top of the range. That's in the 8 Pro, that's about 3,000.
Yeah. It's cost me 54.
Where's the cheap?
Yeah.
And the cheap that, and these will go.
You'd be surprised at the image of the
3 months.
Yeah.
Well, a little bit more.
So it's pop up on here now. So this is
Wow, that's amazing. So that's an app.
so this is the Flir one.
Yeah, yeah,
You've got the camera here now,
yeah.
and when we talk about thermal sensitivity, if I took this table here, same hand.
It's even bigger one.
Yeah.
So that's so even at this range, which is our entry point, you've still got the thermal sensitivity to look up with that. And then on the app, you've basically got the ability to do a still image or a video. You can also have a menu here where you can have, for example, a hotspot. So what it will do is it will automatically pull in on the hotspot point of the image. So you've got a lot of the facilities you have to put with the other cameras.
And this is entry level?
Yeah, this is kind of the classes of the mobile range.
Yeah.
The beauty of this one now though is that you don't need to have USB-C or lightning. It can be used with either.
And it's also very small, so in terms of fitting into a small engine space.
Yeah. Yeah, so you can even leave it set up somewhere.
We also, I mean, I've got one of these.
Have you?
Yeah, I don't take it with me when I'm doing yachts survey, because twice I've managed to bang it. And I've been looking at how useful. I've always got my phone.
Yeah,
Are you looking at GLP with it? And that's the-
No, electrical mean.
Ah,
I mean, the Flir 50 annual is 2 meter drop test. But when you spend all that money,
If you hit it on a sharp edge on an engine.
It's a nice piece
So that
There's a really good.
Yeah.
my insurance doesn't cover it.
Who's that on with that?
I used to have yeah, for 50. Oh, yeah, well, certainly.
so again, generally it's surface temperatures, spots, you can spot small anomalies.
Jason, you're very important.
Well, thank you very much. It has been said before. Although I think last time it was a feed. And again, this is showing the acidity as well, that I mentioned before. So that should all look the same temperature, but that's going to look a lot cooler. Because it's emitting less of the energy because it's shine. It's acidity as well.
When I was selling the system in the suppliers in Indonesia, we used to demonstrate it to roofers and companies. It's incredibly easy because I'm very attractive to system. You sit around, you whack her on the ass. It just
Can't do that, man.
yeah, can't do that. What's the 80s?
Yeah.
Because I won't. That's what surprised me. Been around, technology's been around for.
So we've got in this box here, we've got some electrical simulated box. So you just look at the way.
Yeah. Oh, actually, yes.
Got the ability to just
Oh,
focus on the.
yeah, that's good. I like to see it.
You talk about the
Amazing, yeah. This is revolution. This is small.
Yeah.
Right, so
You've got a fake cut.
Yeah.
Oh, stainless steel surfaces.
I've done a few demos in booths. But when you see here now. Yeah. So it's showing us the.
I have more questions.
Oh, right, okay.
What second-hand model of Flir mid-range would you recommend for multifunction but with good quality? I've been hunting eBay for 2 years, but I can't tell what's worth pursuing.
Get one of them.
$5,000 seems to get something, but
If we look at resolution to begin, the minimum resolution you'd want is 160 by 120, which is what this is. So that is what this is.
My business in Indonesia.
We have other cameras in the range, so we have a C5, which is 160 by 120.
Yeah.
Ideally, 320 240 would be better.
We use that.
So I suppose it's dependent which models at the time. I mean, you could look at like an E8 XT, which is the predecessor to the E8 Pro, so broadly, which is the E8 Pro, so that's about 6 months. So I'd say any of the class them as the EX range. So E6 XT, E8 XT. Again, fixed focus, no lenses to worry about changing, or it's all manual. And then maybe you could even go towards, it depends on the budget as well.
We insist on.
But E54 is one which is available
The electrician.
now, which is actually in this
House.
large format
Your safety.
camera.
Opening everything.
so hi Simon. Simon says I use a Flir on most surveys.
Oh, right, great.
I did the thermography course years ago.
Okay.
The thermal industry is just not geared or knowledgeable in boats and laminates. But in practice, it's very useful to have one broad range tool, the toolbox, to find things for further investigation. The problem is, once you get the genie out of the toolbox, the liability pit can open up.
Nice.
So use with care, and any specific thermal survey is a specialist job.
Yeah.
And it's a specialist separate.
Simon knows what he's talking about.
Gary, Simon, yes, I actually tell clients I have to wait for the hull to warm up.
Yeah.
I have the first version of the Apple Flir camera. And found it useful for finding thermal leaks in insulation as well as exhaust and wiring. I was wondering if a more expensive camera with higher definition would see heat absorption from the environment more readily.
High resolution camera generally is also more thermally sensitive as well. So the combination of those two things, and so there would be a benefit.
Yeah.
But that's going to be weighed up by the budget, the cost,
The cost.
and ultimately how much more of the benefit. So I'd say definitely a benefit.
Yeah.
But you'd have to weigh it up in regards to how much it is.
Brilliant.
So it's been really good.
You have to write an article for me for the report.
Certainly, it's a way to answer before. Just as long as you find the answer to those competent the questions.
Guys, thank you very much indeed. I think that's thanks very much. I understand the very. Even for me, that was very rapid fire. So I appreciate you bearing with me, and I'm you online as well. And thanks for the questions, by the way. If nothing else, it's proved my incompatibility at the moment with marine survey. Yeah.
But it's something I'm going to look further into. So when I come back next year.
Yes, lovely, lovely. Jason, thank you ever so much.
Thank you.
It's been lovely to see you, and safe trip back to your High Wycombe base.
No, I'm based
Probably
in
not.
Merseyside I drove from this morning.
I think you guys are in High Wycombe.
That's because of the elocution lessons.
Thank you for coming down.
Oh, you're welcome. Thank you.
Thanks so much. Okay. We'll have a quick breather whilst we get queued up.
Thanks for your help, David, by the way.
Yes.
We were there, yeah. Touch and go to begin with.